Thank you, John. So again, good morning, everyone. Again, it's a pleasure to be here. I'm hearing an echo. Are you guys hearing one too? No? Okay. I'll work through it then. Again, it's a pleasure to be here. Way back in the distant past, when I was at Motorola, I used to come to MIT often with in the media lab and so on, and with GE Vernova. I'm back here a lot, so it's a pleasure to be here. And from a GE, Vernova, and MIT have started a really big, collaboration project, 5 years, a bunch of fellowships, projects, and so on. And the alliance with the Climate Alliance, we have a big partnership with INM and also work closely with MIMO. So looking forward to this discussion. When they asked me to speak here, they said, are you really seeing the returns in AI? And hopefully at the end of this, I'll convince you that we are seeing some real returns, but we are still very early in our journey. So if we go to the next one here. So just to set a little bit of context about GE Vernova, we are an electrons company. We basically take different forms of energy as nuclear, gas, wind, solar, hydro, and we convert it to electrons. And we span the entire spectrum, generation, from all these different sources that I mentioned, transmission of power, power conversion, storage, and also software that really, orchestrates and stitches together all the different pieces of the electrical grid. As you probably know, the grid is extremely archaic in some places, in need of significant investment, and we have a pretty big opportunity to play there. And then if you look at it just from a scale perspective, 25% of the world's electricity comes from GE machines, and maybe 55% of US electricity. Our equipment is everywhere. Why that's important for this conversation is two things. One, it gives us scale. So whatever we can do in terms of our quality or productivity, it impacts the entire industry, and even field service, it impacts the entire industry. And the second thing is that when you have we believe we have a mission that can impact and change the world. So it's not about just manufacturing at 1% productivity or something like that. So we can really we believe we can change the world, and that's our mission. You'll see that it's electrify to thrive and decarbonize. Decarbonization is a big portion of what we do, and we are committed to that. Although a lot of our sales, I'm sure some of the question will come up if we have time. A lot of our sales tend to be in gas power these days, but gas is definitely a pathway to decarbonization, because in the future, it can run hydrogen, you can use CCS, and so on. Now, quick flyby, it's now 85,000 employees, a bunch of different businesses, 100 plus countries. So, I think we have quite a bit of scale. So since this is the first talk of the day, I'm going to start with a couple of high-level things that you hear in the industry out there. So one of the things is everybody's deploying AI. There's trillions of dollars being spent. You're seeing some massive returns. And if you look at, and the study, when MIT published this study, 95% of Gen AI programs failed to deliver. We had to huddle with our CEO. I had to huddle with our CEO to explain that, no, we are not in that 95% of companies that are not realizing any value in AI. And but I think these kinds of publications, challenge us. They look at the industry. And there's a lot of truth to the fact that companies are not necessarily realizing, value in AI. And, you got other studies out there that you can read. What we've done differently, or what we've tried to do differently, is to really be very methodical and process-oriented in how we implement and apply AI. So we've created this center of excellence. We call it the AI Foundry. And this has got sponsorship from me, from our CEO, Scott. It's reviewed on a very regular basis. There's clear executive sponsorship across the company for AI. And to me, I think that's a really, really important commitment. And, again, we have standardization, governance. I'll talk about that a little bit. We have a couple hundred use cases, but every one of those use cases, the ROI has to be calculated, has to be projected. There's going to be direct, there's going to be indirect. So I think there's a lot of AI is not about the technology and applying the tool. It's in the company, it's about process change. It's about change management. When you do that, that's when you actually realize the value of AI. And what we are seeing is, the big value comes from deep process transformation. Today, I'm not going to touch on those just because of time. But again, end-to-end process transformation across the manufacturing cycle, across the design cycle, that's where we are seeing a big ROI benefit from AI. Now, the other kind of fiction or things that get thrown out there, AI is going to replace all jobs. It's going to take over. It's going to create an economic crisis. I don't have a crystal ball, can't predict the future. I think there's always, much like the Industrial Revolution, there is going to be disruption. There is going to be change. There's going to be some jobs that are going to be displaced. But what we've learned from every big technological change, we see it will also create a lot of opportunities. So two specific examples out here, the radiologist paradox, Geoffrey Hinton, one of my heroes in the AI field. So, and someone I respect immensely. He said, radiologists, you got to stop training them. But if you look at it in 2025, radiology is actually the demand has increased. This is the Juven's paradox. So the demand has increased, and you actually seen more radiologists doing higher value work than they did before. So we see variations of that in our own company. So we're actually seeing we can't hire fast enough in terms of for skills. People that can do AI we are hiring right now to the students in the room. So I think this is something we are definitely seeing in terms of demand. Klarna is another example. 2/3 of their customer service calls were being handled by AI, so they reduced their workforce. They realized they can't do that, and they actually started hiring back. So their workforce is growing again to handle the more complex cases. So it's not about talent replacement, but it's making sure that we have people with deep domain knowledge. Okay. That's probably the biggest font I've seen on a slide, but I think that the talk is about ROI. The investment side is relatively easy, right? I mean, data infrastructure, cleansing, tokens, and just the people. So there's a lot of investment. There's a lot of excitement around AI. What we've learned is you got to be extremely disciplined in terms of what value you're deriving. So putting processes in place to govern it. So that is actually, it sounds simple, but it can, how you do it can be really important. Before I jump to this, so one example is, true cost realization versus cost avoidance. So when you talk about cost realization and, you reduce cost, you reduce, your time, that's easy to measure. But a lot of the time you freed up time and they're using it for something else. So it's cost avoidance that's harder to measure, but the approach we've taken is cost avoidance is gravy, cost realization is what we're looking for. So we measure cost realization. Cost avoidance, we bookkeep it, but that's not a significant metric that drives what we do. Now, in terms of how we think about AI, this is a messaging. We have 85,000 employees. 60,000 of them, 65,000 of them on the manufacturing floor. So the way we communicate AI to our company is exactly like this, and that's what I'm sharing out here. So for simplicity, we think of it in terms of 3 buckets, right? It's enable, run, and invent. Enable is about making sure everybody in the company can use AI. When you hear this fear about jobs, I'm sure you've heard this phrase, AI won't take your job, but someone using AI will take your job. So I think making sure that we have folks who can use AI, who can leverage AI every day, build their, use our internal tools. So AMP is our internal, ChatGPT equivalent chatbot tool, but it's secure. It can use our internal data. It can interact with the outside world. It can use all the latest models through APIs. So this is something our employees can use on a regular basis. This is enabled across the company. Now it has anybody can build their own agents. We launched that 2 months ago. We already have about 6,000 agents. End of the year, we probably will have 50,000 agents. But then, putting the guardrails and governance around it. But this is where we're going to have a lot of innovation, micro projects that'll create good things, and we're not really going to measure that. But the best practices from there will leverage across the company. Run is the operational excellence piece. This is where we actually see the most value from AI today. This is about transforming a process, making sure we have much better quality, making sure we have our documentation. I'll talk about a couple of use cases with RFPs, how quickly we respond, how quickly we resolve field cases. What are the cases that actually come to the operator, and how many of them can be resolved automatically? Code generation. So this is where I would say right now we are probably getting 80% of the value that we're realizing in AI. And then the invent piece is new products and services. This is early days. We're starting to see some really good return on putting AI in our software product. Again, this is critical infrastructure industries, so you have to be careful what you put out there. So I think we are seeing some good return on that. Material discovery. I think Taylor, okay, oh, there he is. He's working on thermal barrier coatings for gas turbines. So what are the new materials that don't have the rare earth materials that are being used today? So there's a lot of design optimization, material discovery that we can work through. And I think this might be my last kind of governance kind of slide, but it's really important for this audience, manufacturing audience. Governance is seen as the cost of doing AI, but we see it as a true enabler for doing AI. You get your governance right, you have the right incentives, you have the right metrics. That's when you can actually realize the value of AI. So we think of it in three buckets, if you will. One is, the infrastructure, all the stuff, the prompts, data pipelines, foundation models, guardrails, all these things, we have to put the right infrastructure in place. And then we have to have, in our model, I mean, this might not work for everyone, but we have a center of excellence where we are working on the latest and greatest in AI. We have a research team that works with MIT, other universities, developing things in AI. We have a foundry team that's really developing the latest tools and processes that can be applied across the company, and also monitoring how it's being used, how we can read across from what's being used in one business to another business, and so on, creating standard work and so on, creating the process. This is about change management. So this enabling governance, what we have found, it's boring, but it's really, really important for success in AI. And impact. Reuse becomes really, really important, especially now. We don't want people creating the same agent like 400 times. So reuse and making sure that infrastructure is obviously going to be heavily reused, code reuse. We are setting up incentives in terms of how much of your code is being used by someone else and how much of someone else's code that you're using. So making sure that there's reuse, and again, it's not a big brother thou shalt, but set up the infrastructure so that it can be done. And then we are looking at idea to value in 3 months. And a lot of the use cases that we are seeing, the 200 plus use cases, we are starting to realize value relatively quickly. We have an MVP, we start to realize value, we implement it one business and scale across to the rest of the businesses. Now, I talked about benefits, direct, indirect. Look at the clock here. So benefit, direct and indirect. Lots of different metrics. I won't spend time on this. Let's get to the more fun stuff. So I'm going to talk about 3 use cases today. One is blade quality control. So you have these, wind turbine blades 100 to 300 feet long. So these are massive, and these are manufactured. The manufacturing processes really come from boat making. So these are still highly manual process. And when you have something so big, maybe 3 years ago, 4 years ago, the way you looked at them, the video, if I click, does it come up? Oh, there you go. When you had a human walk through with a light and a camera and take pictures all the way to the end of the blade. And these blades are big, I think you can see in that video. So you could do that, but you're leaving out places, and then you're inspecting all these images. So we said we could do better. So this is not quite AI yet. It's more robotics in the first step, where essentially we created a crawler. You'll see it in that video. It can go in there, it can go to places where humans can't, and also take a much more 360 view of the entire blade. But it collects 3,000 images that now have to be inspected for the 27 potential failure modes in each blade. So there's delamination, there's resin not infusing, there's stress just all kinds of different failure modes. So being able to capture all of those and then analyze all of those, That analysis part used to be done manually too, looking at images, a human. That is a perfect use case for AI, using vision language models, using generative models, making sure that you can do that inspection 10x faster than what a human could do. So this is a use case where now we have about nearly 7,000 blades. No blade leaves a factory without this blade certificate. So we have almost 60,000 turbines out there, about 180,000 blades. So I wish we had this 10 years ago, but we have it now. But the quality has improved significantly in going out of the factory. So this is a case where a little bit of robotics, not the topic today, using AI to improve our quality. So the principles we operate under are, we call it SQDC. So it's safety, safety always, so safety first, quality always, delivery wins, and cost follows. So we make sure we are hitting every one of those metrics. Better quality, we have faster delivery, we have better cost. So this is one use case where we are seeing 40% reduction in takt times and a pretty significant improvement. Another specific use case that, again, we've seen a lot of value from is the intelligent RFP assistant. And this is where I know how many of you are familiar. Some of you, I'm sure, an RFP for project is a couple hundred pages, lots of details, lots of discussion on a lot of engineering hours spent on responding to the RFP. Again, this is a fantastic use case for Gen AI. Hopefully, most people in the industry this is a use case that can be leveraged. And this is about going into the RFP, attribute extractions, cleaning up the data. And in that phase one, which is completed now, we are seeing about 80% reduction in the time spent on AI. And on phase two, bid evaluation and prep and negotiation, we expect to see they're in process, but they're not fully deployed. We expect to see a 40% reduction in RFP response times with much more accurate responses. Change notices later on and things like that. So we see we've done this for many, many RFPs across all of our businesses, and we are seeing a very significant improvement in our response times. Now, this was built, again, the science is pretty straightforward. Your unstructured data, you're extracting attributes, you're making it available for queries, searches, and so on. The same technology we ended up using for the next use case, which is part of our gas power business. We have 350,000 parts. If you look at our entire business, we have 5.5 million parts. So this was applied to gas power. And what happens in a large company is over time, the number of parts starts to proliferate. So 20,000 new parts are created just in gas power every year. And engineers, when they do the design, if the part doesn't exactly meet their specs, they just create a new part number. You can change it through process. We have processes in place to minimize that, et cetera. But when you have the pressure to create this design and accelerate, you end up creating new parts. But we use the same foundational data. Basically, you go into our parts database. The unstructured data, you structure it. You create 20, 30, 40 variables on which you can query this, and you can find parts that are same or very close that you can reuse. So So one, you can reduce the number of parts. So that's one thing. What that means is you can reduce the inventory associated with holding those parts. It also improves your time to market because you're ordering the right quantity so that you can get better supply for it. Improves your negotiation with your suppliers. So when we started out, we didn't see this as a massive use case, but we also saw, what we realized, is one, we can reuse what we already have, and this is turning out to be this is live. I mean, the other two we've done, we're implemented, it's running. This phase one, it's still in process, but we are starting to see some pretty significant value from this use case. So I touched on 3 use cases. The spirit of this, this presentation is deep in manufacturing. Maybe we can talk about robotics. We can talk about engineering, design cycles, all these places where AI is impacting too. I talked about enable, run, and invent. But really, these are 3 examples of manufacturing cases. We are seeing true value that really falls to the bottom line. This is, EBITDA that falls to the bottom line, and while also improving our SQDC. So those are the three use cases I was going to touch on. Leave a couple of minutes for questions. I think that's all there is to it. But all right, we have a couple of minutes. Happy to take any questions. None? So, yeah.
Expand on, once these pilots are implemented in production, what do you do to sustain it? What that model is?
Yeah, I hear an echo, you don't, so that's okay. So I think, that's what I said, is the change management is far more important than technology. It's making sure we change the processes so that they're actually implemented and they're sustained. So it's the change management process. You have Bruno out here, you have folks that drive that. That is a much more important part of value realization. So you change the process, you implement it. Now there's a standard process that you implement across the factories. So I didn't quite say this, but you don't automate waste. So you have to make sure you lean out the process first. You lean out the process, then you implement AI automation, and then you make sure the process, that's your standard work. That's how you do work. But you always revisit it because the capabilities are changing. What you could do with robotics 6 months ago is different from what you can do today. So you're constantly making sure you're leaning it out and revisiting the process. But once you have the process, it is standard work everywhere in the company. We call it one part, one process. Anywhere in the company, we use the same, for a similar part, we use the exact same process. Now, I can't say with confidence that we've implemented everywhere, but that's the destination. That's what we're trying to implement everywhere.
Thank you.
Sure. Please.
You talked about return, right? The R and ROI.
Yeah.
So how do you prioritize, right? There are use cases which is technically really feasible, but can actually be good return. Whereas there are opportunities where return is high, but technically, yeah.
Yeah, so being in I work with, universities quite a lot. Being in the industry, the return tends to outweigh the interesting problem piece. There's a group in the research team that works on interesting problems that may be long-term return, but they're often the use cases that we chase are driven by pain points. And the pain points are often defined by where you can get the biggest value. So in terms of prioritization is very, very important. So we have 200 use cases. How are we prioritizing 200 use cases? So we are working on all 200, but some of them are smaller, that each team is doing its own thing. There are a few cases, I think 26, that are driven at a GV company level. And this is where the return, the ROI, the dollars, short answer to your question, the dollars tend to dominate the selection process more than the interesting problem. But we know the interesting problems can lead to all kinds of amazing solutions down the line. So that's why our research team tends to focus on that. Please, yeah. Sorry.
You talked about 50,000 agents as your goal. When we introduced dashboards into manufacturing, everybody started to build their own, and suddenly everybody had their own filters, and you couldn't really know whose data was real. I feel the same fear with 50,000 agents. Everybody's going to build their own with their own little custom view. Suddenly, you're not going to have any real trusted source of knowledge anymore. How do you manage that proliferation?
Oh, love the question. So when I think about it, I always struggle with it. Allowing people to, use the tool in a way that best suits them, but also making sure that there's one source of truth, people can rely on it. So the way we are looking at it is, at least at this stage of the game, proliferation is good, because I think we're going to discover what works best. But there's the Foundry team, part of their responsibility is to make sure that they're looking at the agents being created, what's the best of the best, having kind of a marketplace so that people can submit so there's a mechanism for you getting rewarded if your agents are widely used, right? So you have an incentive to create widely usable agents, but there's the governance piece that comes in. We want to make sure these are the blessed agents where it's a source of truth that we can stand behind. Sorry, please, yeah. Oh, okay. Last question. Sorry, I walked away from the clock. I was good until now, but yeah.
saw that in the last project, you had to extract the data from the electrical drawings. That means electrical drawings, digital drawings, and then convert it to electrical and media. So that means there's a requirement for process change where it's already digitalized and then we extract it again. So what kind of process change you guys are following?
So one, they're not always digitalized. So remember, this industry goes back 100 years. So, and it's long cycle. So there's a lot of drawings that are not digital. These are PDF, blueprint drawings that are that are sitting in there. So that's one piece. So bulk of what you saw there refers to getting that non-digital data to digital. But when you have digital data, it makes it much easier. But then it's about defining the right attributes. So you have defining the right attributes so that it becomes a searchable database based on attributes so that you can find similar parts before they kick me out. Thank you, Jen.
Thank you, Krishna. Thank you for a great talk.
No, sounds good.
Give a round of applause.
Good.